Hey guys, welcome to my channel. It's great to have you back. Welcome to all the new subscribers and the new viewers. As you can see, I'm about to board an aeroplane. I'm on tour. I'm signing autographs. Surprisingly, I have a great big fan base in Nigeria, so I'm on my way there. So I'm really sorry I can't be there for the lesson today, but I have recorded this video for you guys just so that you don't miss out on your maths education. So the topic today is going to be on coding, and then I'm going to show you a few resources that you guys are going to be required to complete and upload for the next lesson. Okay, let's get started. Okay guys, so the topic is coding, and I'm just going to introduce you to what it is. So it's basically doing something to all the readings in your data set to make the numbers easier to work with. So it could mean adding or subtracting a number from your readings. It could be multiplying or dividing, or it could be some combination. So what I mean by this is, for example, if you're finding the mean of the following numbers, you can see we have 1831, 32, 36, and 30. You might decide to make your calculations a bit easier, especially if you're doing them manually, by finding the mean of what's left after you subtract 1830 from each of these three numbers here. So once you subtract, you end up with 1, 2, and 6, and you can quite easily work out the mean from that, which is obviously 3. Now, going back to the original numbers, obviously the mean of these three numbers is not 3, so you can use logic and think about, well, actually we're going to need to add 1830 back to work out the original mean. So that's the idea behind coding. So we're going to look at a few examples, and the purpose of this slide is to figure out what the difference is between adding, subtracting, and then multiplying and dividing, but specifically not just the mean, but also the standard deviation, which is what we did last week. So what I want you to do now is, when I say pause the video, you're going to be working out a few calculations here. So this table down here, you've been given an original set of numbers, so it's fairly straightforward: 3, 10, 15, 7, and 8. Just as a quick recap, can you work out the mean and standard deviation? So pause the video now and work it out. Make sure you can do it without any guidance or help. Okay, so you should have worked out the mean and standard deviation. Make sure you can do it. I know all of you can work out the mean and standard deviation, but actually doing it is quite beneficial. Don't just keep playing the video. So here you can see 8.6 and 4.39. Now if you add 3 to each of these numbers, you end up with the following. Fairly obvious. Can you now pause the video, have a go at quickly working out the mean and standard deviation, and use the formulas that we did last week? So pause the video now. Okay, so you should have worked out the mean and standard deviation of these numbers now that you've added 3 to your values. You will notice, and you probably will be able to work this out kind of just through a bit of intuition and number sense. Well, if you've added 3 to each of these, the mean is obviously going to go up by 3. But the standard deviation, which is essentially the spread of this data, the data is not any more spread out. So one way to imagine it is, if you have a number line, if you put your number of data on a number line, I just call this 0. Let's just say these are the numbers that are on your data. We just have, in this case, 4 pieces of data. If you add 3 to each of those, well, that is going to go here, and then this is going to go 1, 2, 3 there, and then this one's going to go there. So essentially you end up with 1, 2, essentially you end up with 1, and then 2, 3, 4. So what you'll notice is the mean of this data has shifted to the right, However, if you look at the spread of the data, so that spread, the spread hasn't changed. They're still spread out by a value, in this case of 1, 2, 3, 4, and in this case 1, 2, 3, 4. So back to this table, you can see that the standard deviation doesn't change, the mean does. Subtracting, you can probably figure out what's going to happen here. It's essentially the same. So if I subtract 2 from each of these pieces of data, my mean will be 2 less, and my standard deviation is the same. Now I want you to pause the video after you work this out. So this time we're going to multiply everything by 10. Here's 1. I've done it earlier for you. So that's just, don't want to stress you out too much with too much work. So 30, 100, 150, 70 and 80. Work out the mean and standard deviation of this. Pause the video now. Okay, so you should have worked this out. So you will have realized that the mean is 10 times bigger, but this time the standard deviation is also 10 times bigger. So when you are multiplying, your standard deviation also gets bigger. Now if I go back to this kind of rough sketch that I've done here, if you look at the way what do you think would happen to your data? Well, if you have, again, your data on a number line, so you have some data here. I'm not even going to do a scale this time. So there's your data. If all of these values are multiplied by 10, this, if we assume this is 0, that would stay where it is. This value would end up down here. That value would end up down there. And essentially your spread of your data is much, much, much wider, or in this case, 10 times wider. And therefore your standard deviation will be bigger. And in looking at division, if you divide all of your x values by 2, you get the following. And then again, pause the video, have a go at the standard deviation and mean. The fact that you're working out the standard deviation and mean so much is actually really good practice. It's like when you're doing the quadratic formula in year 10 and 11. A teacher gets you to work it out again and again. It just helps it embed into your memory. So it's good practice to do that. So now you should have worked it out. If you haven't, then pause the video. So the mean in this case is going to be halved, and the standard deviation is also going to half. Okay, so what I want you to upload is the calculations that show how you got these means and standard deviations as part of your classwork today. So looking at what we've just discovered here, once you have all of these values, we've just figured out that when you have a bunch of x values and you add a to each of those values, well, the mean will be the mean plus a, and the standard deviation doesn't change. When you're subtracting the mean, you subtract a from the mean as well. If you're multiplying everything by a, well, then the mean is multiplied by a and the standard deviation is also multiplied by a, and then dividing by a, the standard deviation is divided by a as well. So this is a summary of all the potential changes that could be impacted by coding your data. Okay, so that you should have that in your book. Okay, and obviously, as I explained before, it's just to make data easier to work with. So this is going to be this would normally be a mini whiteboard activity in class, or at least I'd get you guys to just whisper to your neighbor. So here's an example of a question. A data set has been coded using y equals x over 10. So all of the data has been divided by 10. The standard deviation is 1.41. Find the standard deviation of the original data. So write down what you think it is in your book, which you should have in front of you, and then I'll tell you the answer. Okay, so hopefully you have an answer, and you should have guessed that the standard deviation of the original data is going to be 10 times bigger, so it's going to be 14.1. That's just so you're undoing the coding. Here's a second question. This time you've subtracted 20 from each of your data points, and the standard deviation is 3.41. Find the standard deviation of the original data. Okay, have a go. So hopefully you realized when you're subtracting something from each of the values, the standard deviation doesn't change. The spread is still the same. It's just that all of the items have shifted, in this case, down by 20 units. Here's another question. This time it's combined, so the data is being coded using x plus 100 and then everything divided by 2. The standard deviation is 12.342. Find the standard deviation of the original data. Have a go, pause the video if you need to. Okay, here's the answer. So you can see that when we're looking at standard deviation, the adding of 100 doesn't make a difference, but the dividing by 2 does. So all you have to do is multiply your standard deviation by 2 to undo the division by 2. And here's an example of a question that I want you to do. So this is the time taken to complete reading a paper in seconds. And you can see the table is actually not very well defined because of the boundaries here. You've got 3,000 on each of those. But either way, we're going to work out the standard deviation of this data. Now, the difference between this and the original questions here is this is just a list of data, and here we have grouped data. And so in a question like this, what you would do is you'd probably be given this. You then work out the midpoint. In this case, it's been decided that we're going to subtract 500 and divide by 1,000. So these are now the data points that you're going to use. Once you have that, you can then work out frequency times y. And remember, y is represented by this. So 4 times 1 is 4. And then frequency times y squared. So this would be 4 times 1 squared, 16 times 4 squared, and so on. Now you've been given a data summary here underneath, and typically for A-level questions, you don't really often get questions where you have to do all this number crunching. Like what you will get, as you saw in last week's questions, is the summary data here. It's been calculated for you. What I want you to do now is pause the video and have a go at working out the standard deviation of the coded data. So you have all of this here. Remember, the y is what's important there, because the y means that we're using this coded data here, not the x values. And then work out the standard deviation of the original data. So pause the video now and have a go. Okay, so now I'm going to show you the answer. So you should hopefully have an answer with you. And you can see this is how you work out the standard deviation. And now, because of what we've done when we've coded it, the subtraction doesn't make a difference, the subtract 500 to the standard deviation. The 1,000 does. So what you have to then do is multiply that by 1,000. So that was your variance, sorry, and this is your standard deviation. So 2.19596. When you multiply it by 1,000, you get your original variance and standard deviation. Okay, so that is the introduction to coding. This worksheet, so you can see it's got 4 questions here, 5, 6, 7, and then 2 review questions, along with one final question which relates to interquartile range. this is going to be the core of the work which you're going to complete, or you would have completed in lesson. And there is also just a couple of other things which I'm going to tell you about in a second. Right guys, so that is coding done. And now I'm going to show you a few things that you're going to be expected to do along with that. So this is the worksheet that I just talked about. So I think there's about 7 questions plus a review sheet. This PDF is on Google Classroom along with a few other PDFs. There's special content just for you guys. There is a histograms revision sheet. I've mislabeled these the wrong way around. Obviously that's a box plot on the left, not a histogram, but I'm not going to re-record this. So histograms revision sheet and box plots revision sheet with the full solutions so that you can mark your work as you go through this. Now remember, this the work that has been set is both meant to be 2 hours of lesson time plus at least an hour and a half or perhaps 2 hours outside of lesson, so for homework. I think I've actually given you slightly less work than normal, but obviously me not being there means that you might take a bit longer to do it. So if you have any questions, I do encourage you to work together if you have to, or if you're really stuck. But obviously if that still doesn't work, then you can just send me a quick message. I'm sure I'll have internet connection in Nigeria or wherever I may end up on my tour. And I'll see you guys next week. Hit subscribe, smash that like button, hit the bell icon, check out my Patreon, and I'll see you guys for some great content and maybe even in person soon. All right, ciao.